LeetCode 4, median of two sorted arrays in JavaScript. I'm getting phenomenal performance, and my code is very concise. So I did a pretty good job on this one. Check it out. Given two sorted arrays, nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. So given nums1 is 1 and 3, nums2 is 2, the merged array of that would look like 1, 2, and 3, and the median is the one in the middle. That's what they want. They want 2. So we have to have a merged sort to get our median here, it looks like. But we don't actually need to create an array. We only need the median. That's the trick to making it faster. So if input nums1 is 1 and 2 and nums2 is 3 and 4, then the merged array would be 1, 2, 3, 4. There is no median element. So what we do is we'll take the two middle elements and get the average between those and return them. Return that average. And the median would be 2 plus 3. Divide that by 2, we get 2.5. We can have very large numbers, 10 to the power of 6 and negative 10 to the power of 6 on the other end of the spectrum. The numbers can be of any values in that range, so they can be disparate, or they can be close, they can be repeated digits. We don't know. So we have to make sure that we don't make any assumptions about what those numbers might be, and just go based on whatever we see here. It could be, any number, but those are the constraints. So the way that I do this is to just look at the last two. So I look at the length. All right, so we got a length. We have an even length. So in that case, we don't have an odd length. We have an even length. So we're going to take the last two. We're going to take the last element and the element before the last element. We're going to average those two together, and we're going to get the average between those two. And in the case of an odd number of total elements, length is 2 plus length is 1. That's an odd number. That's 3. 3 is odd. In that case, we will take the middle element from that. We'll just get the last one of the midpoint. So we're going up until this midpoint here. And so in the case of 2, the midpoint element, well, the length would be 0, it would be 3. And if we were to get the midpoint element, it would be not element 2, it would actually be element at index 1. And so that's where we have to make sure that we don't have an off by 1 because of that. Now the way we calculate this, we get nums1.length and nums2.length. That's the total number of elements, and that's how we know if it's even or odd. Right, so if it's odd, well, if len is odd, then we have an odd number of elements in total, and that means that the median would be would be an even number. So it would be like in the case of 3, it would be this one. Actually, it's an odd number. It's 1, right, because it's 0 based. So 0, 1, it would be the second element would be 0, 1. Element at index 1. And the midpoint is the length divided by 2, and then we floor that. It's just we have something to compare it to. Because we don't want to have we don't want to be doing comparisons with floating point numbers. That's just gonna be a little confusing. So we take the midpoint of that. So len divided by 2. In the case of 3, divided by 2 is 1.5. And then if we shave off the decimal point, the floating point portion of that number, we would get 1. So the midpoint element would be the element at index 1 in the case of a merged array that had 3 elements. Index 0, nope, index 1 is the one we want. Then we set up our for loop. Actually, we have a do while loop because that's a little bit faster. And we set up our do while loop. We got some variables here. We got last and before last. Those are the two that we're going to have to count on for our algorithm. And we don't even need the before last when we're dealing with an array that has would have a total number of odd. So if it's going to have a total number of odd, like if this len is going to be odd, then we won't even have to worry about the before last. We'll only have to worry about the last because we're going up until the midpoint plus 1, given that we're 0 based indexes to get elements and that the length is 1 based, and that's how we account for that. So we do this stuff while I++ is less than mid. And then when we're done, we're going to see, well, if we had an odd number, if len modulo 2 is 1, that means if it's odd, then we return the last one. And if it was even, then we return the last one and the one before that. So stepping through this to look at the iterations on what's going on in this crazy loop. And this is where it's only a little place where it's only a little bit complicated. So the before last is last. In our first iteration, when the first call is due, these are both undefined. So before last is last, and before last is undefined, and it's still undefined after the assignment. Last is going to be the result of this expression here. So we're going to first see if nums j is less than nums k, and if it is, we're going to take nums k, and if it's not, we're going to get nums j of 1. If it's not, then we're going to return k of nums 2. I butchered that sentence. So if nums 1j is less than nums 2k, if the index at where we're at in j is less than k, then we want to take the 1 from nums j, and that's what we would be merging in if we were merging the array in. Otherwise, we would want to take nums k because nums j is not less than. The next one would be coming from nums 2 at index k, and we'll keep track of that counter as well. So we'll just take the next one from that one. However, if we end up coming outside of the bounds, like if nums j goes outside the bounds, is undefined going to be ever less than anything else? No. Undefined compared to anything else, undefined, well, that would convert to NaN, and NaN is never less than anything else. That would be if nums 1 at index j were undefined, if we'd reached the end of that array. Now, on the other hand, if nums 2 at index k were undefined, and we'd already gone through all of those, then what do we do there? Well, in this case, if it's null or undefined, and it wouldn't be null, but it would be undefined in some cases, then what we'll do is we'll take our max num. Okay, our max num is, well, we have it down here, 10 to the power of 6, and that's written in this notation here, 10e5. So for this loop, the last one is going to be nums j. In our first iteration, j is 0, is nums j at 1, 3, and that's 1. Is that less than nums 2 at index k? Nums 2 at index k is 2. 1 is less than 3, so we're going with nums j, which is 1. And then we're going to increment that j after we get nums 0. All right, so now we get nums 0, which is 1. That is assigned to last, and j is incremented to 1, as we see down here. So now in our next iteration, what we're going to see is I++ less than mid. First check to make sure it's still looping. I is 0. Mid, what did we calculate mid as being 2? Yes, so, no, sorry, mid was 1. My mistake. Mid is 1. So we had mid as len divided by 2, 3 divided by 2 is 1.5. We shave off the decimals, so mid is 1. Okay, so 0 is less than 1, definitely. So then we continue on our next iteration. Now, before last is going to be assigned to last. Remember, last was 1 from our previous iteration. So is nums 1, remember j is 1 now, is nums 1, which is, the value is 3, nums 1 at index 1, which is 3, is that less than nums 2 at index k? Nums 2, we're still at 0 on k, so k is still 0. Is 3 less than 2? No. So now we're going to go with the second part in this ternary operator, so nums 2, and we're going to take this 2 right here. So nums 2 is going to be used on here. So now nums 2 is going to be assigned to last. So last is going to be equal to 2. Okay, now I is going to be equal to I++. It was 0, and then it was 1. And so now, well, I is still going to be, we incremented it after that. So now I is 1. Is 1 less than mid? Yes, it is. So, and then 1 gets incremented to 2 after we're done evaluating this expression right here. So is 1 less than mid? Actually, no, it's not. 1 is mid. And so then we're done with that. Okay, so we're done with that. So now len is 3. 3 modulo 2 is 1. So then we're going to take the last one off of there. What is the last one? Well, the last one was 2. So 2 is going to be our result. So we're going to return 2. Return 2. And That's how that method works. Now, if we had an even number, what we would do is if len modulo 2, let's say we're getting this example number 2, len modulo 2 is not going to be equal to 1, it's going to be equal to 0. So in that case, we would take the last number, which we would go up to here, up to 3, and the last would be 3, and the before last would be 2, and then we would add those two together, as shown in this example, and we would get 3 plus 2 is 5, divided by 2 is 2.5. So there you have it. I did write on my solutions here, I wrote, I've got a submission here. I also have a crazy one-liner in here. This is just horrible code. I wrote, don't use this code, but it's possible to solve this in a one-liner, just for fun. But this is how you get through it with super fast performance, and it's all explained in here. So if that helps, then you can go ahead and read through my explanation of how this nullish coalescing operator works. You can click through to the MDN, Mozilla Developer Network, web page for the nullish coalescing operator, and that handles the case for choosing the lesser between nums j and k, where nums k is undefined and we want nums j. And of course, when nums j is undefined, nums 1 at index j is undefined, then that would be promoted to NaN because, well, and anytime you compare NaN to a number, it's going to be false, whether greater than, equal to, or less than. Any comparison to NaN is going to be false. So there you have it, folks. That's how to make the code really concise with this nullish coalescing operator. And the nice side effect is that it happens to be super duper fast. So thank you for watching. And we'll just go ahead and click the submit button to run this, just to get the last performance here. We got a little bit less on this on the previous one that I got. We got 99.37 and 99.5. or 95.1, and this one we got 84.1 and 93.7. Still getting phenomenal performance out of it. There you have it. Thanks for watching.